Hello students, this is the 8th video that I prepared to explain how to use the Casio graphic display calculator. Okay, so let us continue. Let us do the 18th one now. Okay, solve the following equations. The first one is ln of x plus 2 equal to 3. I'm going to use the graph. So I'm going to take ln of x plus 2 as y1 and I'm going to take this function 3 constant function as y2. So graph ln of bracket x plus 2 close the bracket 3. Okay, so when I try to solve, find the point of intersection, g solve intersect, you can see that it says not found. Maybe because the solution is not in the domain. So what you need to do is you need to change the scale. So let me make it as, let us say, maximum as 30. Now you can see both the curves intersecting. So g solve intersect. So the answer is 18.08, so 18.1. So for the first problem, the solution is 18.1. So let us solve the second problem now. 10 power 2x equal to 500. Now what I'm going to do is I'm going to deliberately make a mistake, and you'll understand why I'm doing that. So I'm going to take 10 power 2x as y1 and 500 as y2. So graph. So 10 power 2x, so 10 power 2x, so 2x, and y2 is 500. So when I draw, I can't see anything because, as you can notice, y2 is 500. So let us change the scale in y-axis. So shift window, I'll make it as, let us say, 500 or 600. Okay, now you can see both of them intersect, and when I find the point of intersection, sorry, you can see that x is 5, which is incorrect, isn't it? How can, for example, if x is 5, that means the power will be 10. So are we saying 10 power 10 is 500? The reason why we got incorrect answer is because when I typed 10 power 2x here, okay, now the graph, the calculator took it as 10 square into x. That means it took it as 100x. Okay, it didn't take it as 10 power 2x. So what we need to do is we need to put a bracket here. Put a bracket here. Let me put another bracket here. Okay, now if I find the point of intersection, G solve ISCT. Now this will give us the correct answer. The answer is 1.349, so 1.35. So you need to be very, very clear as to where you need to put the brackets and where you don't have to. Okay, so please be very careful. Otherwise, you may not get the correct answer, right? So let us look at the next problem. 19th one. Let f of x equal to 6 sine pi x and g of x is 6e power minus x minus 3 for x between 0 and 2. This is the graph of f, and there is a maximum value at 0.5. The coordinates of b are 0.5 and b. Write down the value of b. On the same diagram, sketch the graph of g and solve f of x and g of x, where x is between 0.5 and 1.5. Very straightforward question. So exit. So let me draw the y1, which is 6 sine pi x. So please make sure that it is in radian mode. The angle, let us check once more. Shift, so run mode, shift menu. Yeah, the angle is in radian, so not a problem. Graph, so 6 sine pi x. So 6 sine of bracket, shift pi, and then x, close the bracket. And the scale is 0 to 2. X-axis is 0 to 2. 0 to 2. And I'll make it as y-axis is minus 6 to plus 6. And the reason is, as you can see that for this function, the amplitude will be 6, isn't it? So okay, now let me find the amplitude. So G sol max, you get y equal to 6. So the value of B is nothing but 6. Okay. On the same diagram, sketch the graph of G. Okay, G is 6 e power minus x minus 3. So 6 e raised to minus x minus 3. Okay, you get this graph. So you need to sketch it. And let us look at the mark scheme. Okay, so I think they have this is the graph of G, and solve f of x equal to g of x between 0.5 and 1.5. So G solve intersect. One value is 0.12. No, that is not in the given domain. 1.047, so 1.05. Yeah, that is between 0.5 and 1.5. And the next one is 1.89, which is outside the domain, outside that 0.5 to 1.5. So the answer is this one, 1.05. So let me check. Yeah, x equal to 1.05. So let us solve the next problem, 20th one. Let f of x equal to 2 plus cos 2x minus 2 sine 0.5x for x between 0 and 3. In the grid, on the grid below, sketch the curve indicating clearly the point P on the curve where the derivative is 0. Okay, so let us draw. So basically the maximum and minimum points, the point P on the curve. Okay, so the function is 2 plus cos 2x, so 2 plus cos of 2x, close the bracket, minus 2 sine 0.5x minus 2 sine 0.5x, close the bracket. Okay, the scale is x-axis 0 to 3, and y-axis minus 4 to plus 4. Okay, this is the graph, so you sketch it. Now clearly indicating the point P on the curve where the derivative is 0. So basically I think the P should be here, isn't it? So let me find the maximum and minimum. G solve. Max, you can see it is not here, it is not found. So let me find minimum. So as I said, this point minimum, isn't it? So G solve minimum. Yeah, I think x equal to 1.735, so 1.74. So the question is, okay, not the, it's mentioned here that you need to mention that point. So let us look at the mark scheme. So you can see this is the mark scheme, this is the mark scheme, and this is the graph, and they have clearly pointed out that particular point where the tangent is parallel to x-axis. Okay, next one is write down the solutions of f of x equal to 0. It is nothing but the roots of this curve. So let us see G solve root. So one value is 1.26, the other one is 2.26. So 1.26 and 2.26. Very simple.